All right. So, okay, guys. So we're going to continue here. One what regarding the H frames, basically, the link uh, doesn't have to have actually any shape, basically, right? What you have to do is you have to make sure that you place your z-axis, which is your axis of actuation, along the motors, basically, right? So if I have this link, then this is going to be my first frame here, right? In this case, basically, it is in reality a property H frames, but it doesn't have to be, right? If you are not using the H frames, you can put any frame. So this could be your x-axis or your y or your z, right? If you are intending to make it a DH frame, basically, you would have to make sure that your z-axis is along your axis of actuation, right? Maybe I can try to give you an example on that, right? So let's say, okay, let's say basically you have your first joint basically is here, right? And then I have, a link like that. And then I have another actuator like this, right? So this is my second link, right? What happens is here is if this wouldn't be a DH frame, basically, right? You can put the frames whatever that you want, right? You could put, your base frame here like X0, Y0, or it could be like your Y0 could be going up, right? But if I told you to place the H frames on here, what are the steps that you have to do? Basically, you have to start by putting your Z0, right? So this is going to be my Z0, right? Which is driving link 1. Then I'm going to have Z1, which is driving link 2, right? And on the end effector, basically, if this was my end effector, basically like the end of the robot, here, basically, I'm free because I don't have any other actuator on here, right? Then after you put your Z0s, you're going to put your X0s, right? So in this case, let's say if I put my X0 over here, and you notice basically when you put X0, you automatically lock Y0, right? Because this has to be an orthogonal frame, right? So X0, now Y0 basically would have to be kind of inward, right? This is my Y0. And notice basically when you are doing these problems, you never actually need Y0, right? As part of the DH frames. You simply just start by putting your Z0s, and then you put your axes or your X coordinate or basically your X vectors on the frames. Now, how do you think X1 would look like over here? Can someone tell me? How should I place X1?
X1 should be perpendicular to both Z1 and Z0.
Exactly. So X1 basically has to be
along the
perpendicular.
link.
Yep, exactly. So X1 has to be perpendicular to Z1 and then Z0. All right. The last frame, it doesn't really matter how you put it, but what I said in my lectures, usually you want to put it, kind of parallel to Z1, right? To make it easier on you, right? So this guy is going to be my, let's say Z3, right? And this guy could be my X3 like that, okay? So once you actually have your frames, you can basically put the origin of these frames, right? So this is going to be my O, right? The origin of the first frame. This guy here is going to be my O1, right? The origin of the second frame. And then this guy is going to be my O3. Why do we use the H frame? So you don't actually have to use the H frame, right? But we use the H frames because if, let's say, you end up buying an industrial robot, right? This is how, roboticists basically can communicate, right? If I have a robot, I don't actually have to give you the exact CAD model of it, right? I will simply give you a DH table. And once you have the DH table, you can actually do the inverse kinematics. Basically, you have like the skeleton shape of the robot. All right. Just a brief feedback on on here is what we said. If I have H01, right? What is H01? If I told you to find the transformation between frame 0 and then frame 1. So frame H01 basically is all you're doing is basically you are representing this vector in here, right? So this would be basically X10, and then you have Y10, and then you have Z10, and then you have the coordinate of point 01 in frame 0, basically, right? So this guy is going to be 010, and then instead we put 0, 0, 0, and then you're going to be putting 1 here. Okay, so we've already done that. You can do H01, H12, right? And by the way, this guy could be frame 2, by the way, not frame 3, but doesn't really matter. So you can do it directly frame 1 to 3. Any questions, guys, on this? On the exam, like, I would give you something like this. I would give you like a vector here, right? I could give you like, a point, that is expressed in frame 3, right? So this robot would be seeing that point, it would have some coordinate along x3, y3, z3. And if I tell you, find the coordinate of that point in the base frame, how would you do that?
We have to get the homogeneous transformation between frame 0 and frame 3, or the DH.
Exactly, right? So basically, you
Doctor,
would
we
have
will
to
be
find.
free to use MATLAB or we have to solve by our hands.
You can use MATLAB. So on the exam, I will simply ask you guys to send me whatever work that you've done, right? And if you want to do it in MATLAB and then print it out, by all means, you can do it on MATLAB.
Okay. So we can do on MATLAB and send you the MATLAB file.
You can do it in MATLAB and then you can send me the MATLAB file. Yes, provided that you do everything in a single file.
Yes.
Okay.
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 And
So
will
if
you
I do,
post the solution of the homework?
I will. Yes, I will be posting the solution of the homework. Yep.
Okay. Thank you, Doctor.
And by the way, what was H03? H03 was what? Was H01, right? Multiplied by H12 multiplied by H23. Okay. And basically we have all of these. And then each one of those is basically a function of the DH variables that were provided for these links. Okay. So make sure you really go over these lectures, especially the DH lecture, because, definitely we'll have a question on the DH parameters. And what I want you guys is, if you guys have any question, by all means, I'm always available. You can just send me an email and then we can schedule a one-on-one meeting where we could go over them and make sure that you understand what is going on.
Doctor, I have a question on the last exercise that you've solved in the recorded lectures.
Yeah, sure. You mean the rest, probably, right? This guy.
Yes.
Okay. What's your question?
Okay. So just 1 minute so I can maximize it. Okay. That's the first time where we put actually the origin of the second frame on another actuator. So we're actually allowed to put the origin of our frame like in any place. Actually, it's not this one. We had at the end we had the end effector.
Yeah. Okay. Let me see. Okay, but it was a resto, right? Like something like that, but we have a rest.
Yes, but then we had 2 frames with the same origin, and then we had one end effector.
2 frames with the same origin, and then you have an end effector. Okay. Yeah. So your question is, does the origin have to be on the part itself, or it could be like outside the actual?
Yes, like for example here, the X3Z3, we can move it, so put it on the first actuator.
On a second actuator, you mean?
Yes, the second one.
Yep, exactly. Okay, so when you are using a DH frame, right, the origin of the frame doesn't have to be physically on the actual, doesn't have to be on the actual link, right? Okay. It does not have to be on the actual link. And what I will do is I'm going to give you guys an example, and this was actually an exam problem last time. Okay, if I give you something like this, okay, if I give you something like this. Okay, so we're looking at this robot is basically in this plane, right? And if I tell you that this robot looks like that, okay, it's moving this guy, and here basically I have a prismatic joint. Okay, so let's take a look at this robot. Okay, if I told you to place the DH frames on this robot, right? How do you do this? I'm gonna do it now. So we're good. So what do we first begin by doing? So this is the first actuator, right? And then this is the second actuator. So this is a rotational joint, and then this is a prismatic, right? So this guy will basically translate. Does it make sense? Okay, can someone help me out if I want to put the DH frames on this robot?
Yes, doctor. The Z0 axis will be the actuator of the rotational outside.
Exactly. So the Z0 is going to be basically perpendicular to the paper, right? And now remember, right? Z0 is driving link 1, right? Z1 is driving link 2. Okay. So, when you're talking, in an abstract math basic, if you're looking at the actual robot, what is actually happening is that you are putting a frame on the ground, right? So you're treating basically the ground as a link, which is fixed. Then you want to put a frame on the first link, right? Like Z1 basically is sitting on the first link, and then link 1 is driving link 2, right? So you put frame 1 is going to be attached to link 1. So no matter how link 1 move, frame 1 will actually move with it, right? If you're like working on a, some animation or whatever, you will always see that frame 1 is actually locked to link 1, right? And then frame 2 is on link 2. So frame 2 will actually move with link 2, right? But we know that frame 1 will actually move frame 2, right? And link 2 basically is connected to, frame 2 is connected to link 2. Okay, so if I want to put Z1, what can I put Z1?
Along link.
Anywhere on the first link.
Along the link.
Yep, exactly. It's going to be along the link, right? So this guy is going to be Z2. So it's a free vector now, right? So the vector basically, and then this guy is Z1, right? Okay, Z1 is, guys, attached to that link. مظبوط. Z1 is, right, is the axis of actuation here, right? It's attached to what link? It's attached to this link, okay? How about Z2?
Anywhere, it doesn't matter. It's the end effector.
Okay, so Z2, guys, has to be attached to this link, right? This is the moving part of that link, right? So exactly, it doesn't matter, so I'm gonna put it here, okay? Now, the second thing is I need to find X1. How can I put X1?
Perpendicular to Z1 and Z0.
Okay, so can I put it here, for example?
Should be parallel to X0.
Can I put X1? Can I put X1 like that?
مش لازم تكون connected to Z1 يعني it works like this. It is parallel to Z0 and Z1.
No, we said it doesn't. It's not about being parallel, right? So you have to basically apply the equation. It has to be perpendicular, right?
Z1 and Z0.
Exactly. It must be perpendicular to both Z1 and Z2. I'm sorry, Z1 and Z0, right?
Doctor, but I also read that X1 should also be perpendicular to Z1 and 0 and also should intersect Z0 and Z1.
And it should basically intersect Z0, exactly. Yeah,
Yes.
it has to
So
intersect.
in this case, it doesn't intersect Z0, so it's wrong. It cannot be there.
Exactly, it cannot be here, right? So it is perpendicular, exactly. Yeah, well, obviously I meant, it has to be also, intersect Z0, right? That's what we, mentioned in the DH lecture, basically. It has to be perpendicular to both Z1 and Z0, right? So where should I put it then? Where should I put it? Is this valid?
No, it's not valid.
Okay, so then how?
I guess the only place that it's perpendicular to both Z0 and Z1 and intersects Z0, it's on Z0 itself. Yeah.
Exactly. So it actually, there's only one solution here, right? There is basically, this is a deterministic problem, basically, right? There's only one solution to it, right? So X1 actually has to be here, right?
Yes.
Okay. So X1 has to, so this guy here is wrong, right? So X1 is perpendicular to Z1 and is also perpendicular to Z0, right? So now if I want to actually put the origin, and this guy is obviously going to be O, then this guy here is going to be my O1.
O1.
Okay. How about O2? Where should I put X2?
هون على فينا نحطها هون على الآخر. Yes.
Exactly. So the reason why I want to put it here, because obviously I want to be able to describe where my end effector is, right? Where the robot end effector is, right? And then this guy is going to be my O2. Okay. So what actually really happens is that this frame is connected to what? This frame is connected to this link, right? So as you rotate this guy, X1 is, rotating, right, along with that link. All right. Second thing, if what is the next step that I would have to do? I would have to put basically my thetas, right? So in this case, this guy could be my theta 1, and this guy from here to here is gonna be my, like a value D, for example, describing that distance. And when you are doing your, your DH table, okay, let us quickly do the DH table here, right? So what do we say we have? We have, can someone remind me what is the DH table? How does it look like?
Yes. The AI, alpha I, DI and theta
We
I.
have A, alpha, مظبوط, D,
Theta.
and then theta. Okay. Okay, so we have here two links, right? So 2 degrees of freedom. So this guy is going to be for link 1, and then this guy here is going to be for link 2. Okay. All right. So let's find what is A in this case. We said A is going to be the distance between what? I think A is the distance between the z-axis. مظبوط?
صح.
Okay. So in this case, what is A? A is going to be that distance right there, right? Let's actually call this guy A1. Okay. So this guy is going to be my A1, right? I would know the geometry of the robot. And A1 basically is also measured along X1, right? So if X1, if you chose basically X1 to be pointing downward, right, then A1 will basically be the opposite of that, right? So make sure you are, when you are applying these DH frames basically, or when you are putting these parameters, you're actually looking at the actual definitions of these as were listed.
Doctor, A is listed distance between Z0 and Z1 in the course, and
Yep. Which
just not along X.
Right. In reality, it is actually along X1, right?
It should be along X1, يعني?
Yep, it will be along X1.
Okay.
Okay. All right. So how about alpha? What is alpha in this case? So alpha, we said, is going to be the angle, right? So just based on a definition, right? Alpha is the angle between, you know, if you are looking at alpha 1, is going to be between Z0, right? And
Z1 along X1.
exactly. So this is Z0 and then this is Z1 along X1. So how much do I need to rotate Z0 to bring it to Z1 about X1?
Uh, 90 degrees positive.
Exactly. So it's pi over 2, right? So you rotate Z0 about X1 by pi over 2 to bring it to Z1. Okay. And by the way, guys, one of the good things about, you know, using MATLAB is you get to validate this, right? Sometimes, you know, you may not be sure if this is minus or positive. The best thing to do is what? Just put it in MATLAB, right? And then plot the robot, and then you will validate it, right? You know, the analytical solution will obviously help you to, you know, write your initial script, but you can validate that by plotting the robot, and then that way you're that sure basically this is what is actually happening. Is this positive or minus, for example, right? Okay, next is D, right? We said D is the distance between what?
X0 and X1 along Z0.
Yep, exactly. So what is D in this case? D is 0, right? Okay.
Yes, because parallel.
Exactly.
X1
So
and
X0 and X1 are on the same plane, right? And then how about theta? Theta is the angle between what? Between X0 and X1. Okay, so if I actually put X0 here, what is theta?
minus 90, I guess.
Okay, so what is the definition of
90.
theta? The angle between X0 and X1 about?
Along Z0.
So
Yeah.
you're looking at this angle from this vector to this vector, right? The angle is always an angle between two lines, right? So the angle between this line and this line is what? So if I actually put theta 1 here, if I wrote theta 1 to be from this line to this line, then what is the actual theta? What should I put here? Right? So I need the angle from this vector to this vector.
We just place theta 1.
Okay, so theta 1 is the angle between the x0, right? And this guy, right? I just, you know, I choose to put it like that, right? I put theta 1 like that, right? Theta 1, by the way, has nothing to do with the DH frames, right? Theta 1 is, I can put theta 1 whatever. Basically, this is simply an angle that I'm putting, right? The DH frames is actual putting these x's and then these vectors on this robot, right? If I actually put theta 1 here, what should I put here for theta? Exactly. Someone said,
Pi over 2 plus theta 1.
exactly. So it's theta 1 plus 90. Exactly. So it's theta 1 plus 90. So here, when you are doing your DH function, you will actually put theta 1 plus 90, right? Okay. How about for link 2? What should the DH frames
Doctor, can you repeat it, please? I didn't get it.
Yeah. Okay. So what I said, when you are putting your DH frames, basically, right? the values of thetas and d's, or whatever geometrical parameters you have on the robot, has nothing to do with the DH frames, right? When you are putting the DH frames, right, you are done at the level of putting your z zeros on all the actuators and then also your axes, right? Then when you are putting the geometry, basically you will simply look at the definition of, let's say, A, and you list it basically based on the geometry. So if I'm here, theta, what is the definition of theta? So the value that actually has to go in this box, right? The value that has to go in this box is going to be equal to the angle between x0 and x1, right?
Okay.
What is the value between x1 and x0 and x1? So I already have theta 1 here, but I know this guy is, a 90-degree bracket, or right? So this guy, this angle has to be theta 1 plus 90.
Plus 9. Okay.
Okay.
Okay. Thank you.
So to actually put the actual value here, right? How about the DH transformation between link 1 and then link 2, right? So what is this guy? This guy here will give me what? DH 0 and 1, right? This is a geometrical representation between ground and link 1, okay? So how theta 1 move, basically, I will be able to capture the position of O1. I'll be able to capture the position of X1 and then Z1 as theta 1 varies, right? Now let's look into link 2. What should I put here for A1? Okay, we said A is going to be the distance between the z-axis, right? So look.
0.
Okay, so we said A is going to be the distance between z-axis. Okay, so Z1 and Z2 exactly, which is 0. Yep. How about alpha? The vectors are parallel, so this will also be 0. How about D? D is the distance between the x-axis, right? So x1 and x2. So this guy is actually D, right? And then D here is variable. Okay, usually what you want to do is, so we're referring this guy as theta 1. This guy, you can call this guy D2, right? Why you want to call it D2 basically is you are basically finding the position of frame 2 basically, okay? It doesn't matter, you can call it any variable, okay? So I want to call it D2 so because it's in a row 2 basically. How about theta here? What is the angle between x1 and x2? Right? Angle between x1 and x2 about x1? About z1, I'm sorry. So am I actually rotating x1 to get to x2 about z1? Nope, right? So this guy and this guy are, right, in the same plane, right? So z1 is not rotating x1 into x2. So if I actually put one more joint here so I can actually rotate my end effector, then I would actually introduce that. Does that make sense? I could choose to basically put a rotational, like a motor here, like an inline motor, so I can actually rotate the end effector, right? In that case, I would actually add another row, right? And we would actually be rotating this vector. So in that case, it's going to be 0, okay? So I think that's it really regarding...
Doctor, I have a question.
Yeah, sure.
Is there a reason why you took x0 like that? Couldn't you just avoid using theta 1 and take it along the line?
Absolutely.
So you would have 90 degrees between it and between x1?
Absolutely. So you can do this. You can actually make theta 1 all the way to here, right? It doesn't really matter. So whatever that, so I can actually make theta 1 like that, right? In that case, I would knock out the 90 here, okay? But when I'm plotting the robot in MATLAB, if I put theta 1 to be 0 and then D1 is 0, basically, I would be plotting the robot in what configuration? I would be basically plotting the robot. So if this is my x0 and then this is my y0, how do you think it would look like if I was plotting this robot based on this theta 1, right? So I put the geometries, right? I put my DH frames. We want to review basically the lecture that I posted, how you plot the robot, right? How do you think the robot would look like in MATLAB if I was plotting it and theta 1 was 0? So basically x1 is going to be pointed along x0, mazboot. If x1 is pointed along x0, so this robot is going to look how? It's going to look like that, right? So x1 is somewhere here, right? Okay, so if I was plotting it, right, based on that, so x1 is going to be like that. Then this guy, the robot would be like this, right? Or wait, x1 is not here. x1 is actually shifted, right? So basically, this guy would be rotated all the way down, right? For x1 to be here, right? So if this angle is 0, right? It's like, this whole thing is basically flipped down, right? and if this guy is here, right, x1 is going to be along this guy. Okay, how would that look like? So if this guy is here, then this guy would be going downward, right? So this guy is going to be here. This guy is going to be like that. Wait, okay. Okay, so basically, if I'm at the home position, basically, let's say everything is 0, right? Well, obviously D here can't be 0. In this case, we have to have some offset for it, right? But we are simply calling this guy, this whole thing as D. So it could be sometimes you actually have some constant value, plus you actually have the D to it, right? So here we're putting this whole thing like that. So if I were to actually, let me actually start on a new paper so we can actually.
Doctor, the base frame should not be a moving frame, right?
No, exactly. The base frame basically is fixed, right? And always your x0, y0, or your z0 basically will be connected to a fixed part, right? It's going to be to, you know, the redundant link or the ground link,
Yes.
which is not moving. Okay, very briefly. So if I was actually doing this like that, this is my x0, and then this is my y0, right? We said x1 is going to be here. Okay, this is my x1. Oh, wait, no, this is my x1 here. And then this is my z1, okay? If I were to actually, and then if I said, if this guy here is theta, if I define my theta here, right? What is the benefit of doing theta here? If I defined my theta 1 to be here, then if theta 1 is 0, then I know the robot is going to be in this configuration. You guys agree? If I defined my theta to be here, all this value, and this guy is 0, it means that what would be my 0 configuration? My 0 configuration will be this portion of the robot would actually be along, this guy here is going to be along the Z0, right? Because this guy is going to be here, right? And then we're going to have this portion is going to be like that, right? And then, okay, can someone help me to do this? How would that look like? If your x1 was 0, right? If you were plotting basically that in a frame in, if theta here was 0, right?
بس
If this
دكتور
value here
حتى مثل ما انت عملتها هيك داش ونزول.
Okay, so we have that. Okay, so let's do that. Okay, so it will be all the way down, right? Exactly. Okay. But what will actually change is that, you know, this guy, you won't see that part. So this is a robot. Okay, here you go. So this is the actual robot. This is how it would look like. So choosing basically, okay, right? So this is a dash, so you don't see that. This is the actual robot right here. All right, so defining, simply changing how you're actually putting thetas, right, will actually simply change your home position basically, right? What is
Doctor,
zero
but
in the
usually
robot?
in robots, do they limit the angle? يعني مش هخليها تقفل 360 ولا sometimes they usually limit the angle مثلا between 0 and 90 مثلا أو شيء هيك.
Yep, exactly. Yeah, sometimes it would be limited, so you will simply have to look into the offsets of the robot, etc. Okay.
Yes.
However, what I want you guys to know for the exam is you have to be fully familiar with this process, right? You know how you're putting the DH frames, right? You know your you're putting the, first of all, you're putting your axis of actuation, right? Then you're putting your x axis, which have to be perpendicular to your, you know, current z vector and also the previous z vector, and it actually has to also intercept the previous z vector, right? So it has to be perpendicular to both, and it actually has to cross the previous z vectors. Okay. Any other questions, guys, on this? Okay. What I would like to do today is I want to briefly cover inverse kinematics, and so far what we have been doing is this is more like, you know, forward kinematics, right? If I give you, you know, theta 1 and I give you the value for d, basically you can tell me where this guy is, right? By finding the homogeneous transformation. Right here, from this you can find, you know, H01, and you can find H12, and then you can find H02 to be equal to what? H01 multiplied by H12. Once you have H02, you basically have the full kinematics of this guy, right? You have Z2 in frame 0, you have X2 in frame 0, you have O2, the coordinate of this point in frame 0. So this is the forward kinematics. Now, what is inverse kinematics? Inverse kinematics is more about actually, and I will actually do this based on an example, okay? Let's look into this type of a robot, basically, like a two-link robot that looks like that, okay? Let's say you have a robot that looks like that. This is your X and then your Y. This is my theta 1, and then this is my theta 2, okay? Let's say the end effector, the coordinate of the end effector is XE and YE. Usually in industrial applications, right, I actually know, or I have a point where I would like the robot to go to, right? And what I would like to do is I need to have some model to be able to tell me what should theta 1 be and theta 2 be in order for the robot to be at this position. Okay, so what you are doing in inverse kinematics is you are finding, you know, let's say F1 is a function of XE and YE. So you are basically, inverse kinematics is you are finding this analytical function, F1. So given XE and YE, you find theta 1. All right, and then you're going to find another function, F2, that will actually give you theta 2. If you have a 6-axis robot, basically you have theta 1 to theta 2 up to theta 6, right? And then you'll have 6 different functions, right? Or solutions to this. Okay, so this is inverse kinematics. Usually inverse kinematics is abbreviated as IK, all right? How about forward kinematics? Forward kinematics is what we just did earlier, right? Forward kinematics is XE, right? Let's say G1 is a function of what? Theta 1 and theta 2, right? And YE is another function of theta 1 and theta 2, right? So this is called forward kinematics, and it's labeled as FK. Okay, so this is IK, and then this is FK. When you have IK or inverse kinematics, basically sometimes you could actually have 2 solutions to actually reach that point. Can someone think of another solution to actually, you know, schematic solution that would actually come at this point? Right, so if I want to put the robot here,
انه بتطلع الثيتا 1 وبترجع بينزل الثيتا 2.
exactly. So I have 2 configurations basically, right? Here we're not talking about post, simply we're talking about the end effector reaching that point, right? So the other solution for this would be theta 1 would be here, right? And then what would be theta 2 in this case? In this case, we're defining theta 2 as the angle between this link and that link. So this guy would be theta 2. Okay, so you're basically solving both of those. Okay, why don't we now close the session and then start another session where we'll actually go into the kinematics of this and then start doing a bit more on that. Okay,
Okay.
close the session, log back into the same link because we only have 2 minutes left on here.